Let's move on to the next question about angles of elevation. Now this one is more complicated. We have a hot air balloon, alright, we call it B. We make two observations from points P and Q, alright. This should be point P, alright. We make two observations from points P and Q. Now, but P and Q, they are not lying on the same horizontal line. It's lying on the slope, alright. The slope, the inclination of the slope is the 15 degrees, alright. The pink angle here is the inclination of the slope. Now, first of all, we have the angles of elevation from P. I mark it in the purple angle, it's 60 degrees. So where do you think 60 degrees is on this diagram? If you think 60 degrees is this angle, then this is wrong. Alright, this is not 60 degrees. The angle of elevation, like I mentioned earlier, does not measure from the slope. It measures from the horizontal, right? It's not this one, but rather it is this one, the green one, alright? So in this case, the angle of elevation is not measured from the straight line PQ. It's measured from the horizontal. So this entire purple angle will be 60 degrees, alright? This is how we make sense of the angle of elevation from P is 60 degrees, alright? Now, the examination question would put the data in the description rather than the diagram. So you have to put back the correct numbers into the diagram. This distance PQ is 200, alright? And then how about the angle of elevation from Q? This is the one that people make most mistake. 35 degrees. So many will say, oh, so this is 35 degrees because that is the angle of elevation from Q, alright? So if you pay attention to my previous video, you know this is wrong. This is not how we look at 35 degrees from the slope. We measure 35 degrees from the horizontal line, always, alright? The angles of elevation, angles of depression, always attach themselves to the horizontal line, alright? The angles of elevations, angles of depressions, always attach themselves to the horizontal line, alright? So this is it. I put back all the information back onto this diagram. So once again, we want to find H, alright? The height of the balloon above the P, above the ground level. So the focus triangle in this case will be the triangle PBQ, alright? This is the triangle we have most information on. Alright, but straightforward information, we got only one piece, that is the 200. Alright, 200 between P and Q. What else do we know? We don't even know a single angle directly, but we can get these angles indirectly. For example, we can get this angle BPQ by subtracting 15 from 60. Alright, the purple angle here is 60, but the pink angle is 15. So the difference between them here, let me put that in yellow, will be how many is that? Will be 45 degrees, alright? This 45 comes from 60 minus 15, alright? This is 60 minus the 15 degrees, so that we have the 45, alright? And what else do we know? Do we know the top angle? Right? Do we know the other angle? Angle BQP. Do we know this one? Alright. Turns out we have this orange angle. Right, now you need to have one more thing. You need to, because the two horizontal lines, they are parallel to each other. Alright, so you can invoke the idea of alternate angles. Alright, this pink angle 15 degrees also appears here because these are a pair of interior alternate angles. Alright. So when you come to 2D problems, this idea, they are important, alright? It's not just a laid bare triangle. You can use the angles and lengths. Those angles and lengths, they are hidden indirectly, alright? So this orange angle will be 35 plus 15. Am I right? And that orange angle turns out to be 50 degrees, alright? So once again, it is a classical ASA situation. In ASA, we need the top angle as well, right? The top angle, let me put that in blue, alright? How much is the top angle? It's 180 minus 50 minus 45. It goes to 85 degrees, right? So we can use the ASA formula to find PB or maybe QB, right? Use ASA sign formula to find BP, all right? Or alternatively, you can find BQ, all right? And then once you have BP, I think BP is better, right? Because we need H, all right? So BP is better. BQ does not relate to H, but BQ does not relate to H, all right? This line has very little information regarding to H, but this BP is more useful because they form a right angle triangle with H, all right? So I will start with BP, I'm sorry. All right. Once you have BP, you can invoke the sine ratio. All right, BP and H and the ground, they make 60 degrees. All right, so you can use the sine ratio to get H. All right. So once again, the gray arrow comes in. This BP goes all the way here. Once you have BP, you can, in triangle PB, let's call it A, all right, PBA, you can find H using sine ratio, all right? Shall I leave the calculation to you? All right, I think you can work out the calculation on your own. Treat it as an exercise. Using the ASA situation, find the length of BP. Once you have BP, you can use the sine ratio to get H, right? This is kind of like a battle plan, right? We have to have a plan before we work on the solution. This is our battle plan, all right? We find the yellow angle and the orange angle using the angles of elevation and some of the parallel lines idea. So now we collected sufficient information, ASA, in this focus triangle. All right. In this focus triangle, we get the length of BP, and then we fit the BP into the right angle triangle with H, so that we can find H. All right. Now, while I'm speaking, I think you can finish the answer. The H in this one is 133.2 meters. All right, to 1 decimal place. All right, so it's a more complicated problem on angles of elevation and angles of depression, right? Especially, mind you, try to avoid the misconcept of taking the wrong angles here, right? These two, purple and the green angle, how do you put them in the diagram is the most important thing in this question. So this is the end of the second part.